Dear students, until yesterday we handled the topic mean value theorem in 1B track. Now let us re-enter in 1A track. In 1A track we are handling vectors. In the vectors we have completed dot products and cross product of vectors. Regarding triple product of vectors, today's topic is triple product of vectors. Triple product. Among the topic triple product of vectors, there are two types of triple product. Triple product of vectors. First one, scalar triple product, and the second one, vector triple product. Among the triple product of vectors, now I am going to discuss about scalar triple product. Scalar triple product, later vector triple product. Today topic is scalar triple product. Let us discuss concept of scalar triple product. Put side heading scalar triple product. I will say the definition of scalar triple product and properties of that product and everything today we can discuss. If A bar, B bar, C bar are any three vectors, if A bar, B bar, C bar are any three vectors, then A bar, B bar, C bar are any three vectors, then the dot product of a vector, the dot product of a vector A cross B, dot product of a vector A cross B with another vector C bar, with another vector C bar is R. This can be notated in other way also. R dot product of a vector, dot product of a vector A bar with another vector B cross C, B bar cross C bar, is called as triple product of, that too scalar triple product of vectors. Scalar triple product. Scalar triple product of vectors. It is denoted by A bar, like this definition. According to first one, we can write A bar cross B bar dot C bar, or A bar dot B bar cross C bar, and it can be read as this one. It can be read as box ABC. Box ABC. Notation is like this. This is box ABC. Box ABC is the scalar triple product of vectors. Triple means three. A bar, B bar, C bar are three vectors are there. Dot product of A bar with B cross C, or dot product of A cross B with C bar is called as scalar triple product of vectors. We know that A cross B, this is a vector product. This is a vector, and if we multiply the vector with another vector with dot, it becomes scalar. So this is denoted as scalar triple product of vectors. Otherwise this one also, A cross B, this is a vector. B cross is separate vector, this is separate vector. Whenever dot is exist between the two vectors, then we can say that A bar dot B cross C is the scalar product of the vectors. Scalar product of the two vectors we can say. Next, let us denote the ABC, box ABC notation I am saying. That was first point. Now let us discuss about second point. We can denote that if A bar is equal to A1i plus A2j plus A3k, notation like this. If A bar is equal to A1i plus A2j plus A3k, B bar is equal to B1i plus B2j plus B3k. B1i plus B2j plus B3k. And C bar is equal to C1i plus C2j plus C3k. Then box ABC can be denoted as, its notation can be represented as determinant of, the symbol is determinant. Determinant of A1, A2, A3, and here B1, B2, B3, and here C1, C2, C3. This is the determinant. Box ABC notation. Let us discuss about third point. If A bar is equal to L bar A1 plus like this, M bar A2 plus N bar A3, comma, B bar is equal to L bar B1 plus M bar B2 plus N bar B3. Next, C bar is equal to L bar C1 plus M bar C2 plus N bar C3. So, the notation of box ABC can be represented as, here, box ABC can be represented as L, M, N box, because this is a combination of vectors with scalars. LA1, L bar A1 plus M bar A2 plus N bar A3 can be tried to understand as R bar is equal to XA bar plus YB bar plus ZK bar, ZC bar, XA bar plus YB bar plus ZC bar, or XA plus YJ plus ZK. Like that here A1, A2, A3 are scalars and L bar, M bar, N bar are vectors. So here you can try to understand, and you can write the box ABC value as box LMN into determinant of here A1, A2, A3, B1, B2, B3 and C1, C2, C3. This is the box ABC notation. In next one, we can represent the example I am saying. About this sum, let us write an example. Box A plus B, B plus C, C plus C I am writing. Box A bar plus B bar. Box A bar plus B bar, box B bar plus C bar, box C bar plus A bar. This notation you can try to understand as box A, B, C taken common, and the components you should write here. 1 for this one, 1 for B, 0 for C, there is no C, that is why I have written 1, 1, 0. Here box B plus C is there. So here A is not there, 0, 1, 1, A, this one, A, 1, 0, 1, like that. Now we should calculate the derivative. What is this called? Determinant value. Box ABC. Box ABC into, we should calculate the determinant value 1 into 1 minus 1 into 0 minus 1, it becomes minus 1. That is equal to, you can write here the value 2 box ABC. Somebody used to say simply it is the determinant is 2, but you should write the value of the box A plus B, B plus C, C plus C is 2 box ABC. So like that you have to take common the vectors as the box. Here also wherever vectors are there, you should take common and you should calculate the derivative of the scalars. Now let us discuss about characteristics of box ABC. What are the characteristics of box ABC means? It is depends upon the dot and cross both products. So the formulas are applicable, wherever the formulas are applicable for box AB, cross product and dot product. So two characteristics we should discuss here. Fourth formula. Box ABC I am writing here. Box ABC can be written as box A cross B dot C or A cross B, A dot B cross C. So we can write here box ABC, here minus B cross A, minus B cross A dot C. Here also you can write A dot minus C cross B. minus C cross B dot A dot like that. So you can write here minus box BAC, minus box BAC. You can write here minus, you take common, minus ACB, minus ACB. So you try to understand that whenever you change two letters, it becomes minus. And whenever you change three letters completely, three letters we can change, it becomes minus of minus. So box ABC is equal to box CAB you can write. Because C is the third letter changes to, becomes to first letter. So minus of minus. Box ABC is equal to box CAB. You can write box ABC equal to minus box BAC or minus box ACB. This is box CAB. Again, if you change this one, the only two letters you can write here box ABC simply. Using this one, we can write IJK. Let us discuss about IJK concept. Let us write box IJK. Wherever I bar, J bar, K bar are unit vectors along x, y, z axis respectively, we can write here I cross J dot K. I cross J dot K. We know that the value I cross J dot K, K dot K is equal to 1. So box IJK can be represented as 1. Next, let us discuss about IKJ. What happened here? Just one letter changed. So we can write here I cross K dot J or I dot K cross J. I dot K cross J. So I cross K, we know the value minus J dot J or I dot K cross J value minus I. This is I bar. So minus 1. Here also minus 1. You can understand this value. So like this you can write the order IJK. So IJK order is equal to I am writing here KIJ. IJK, third letter change, third letter became to first letter KIJ. Next one IJK, KIJ change, next letter we can change IKJ here. Whenever second letter change like this, we can write minus IKJ and is equal to, we can write the letter minus IJK also. Whenever JK changes, so KJ as. Now you can write this one minus JIK. And you can write the value, these are all equal along with minus symbols. So depends upon IJK concept, we can write an obvious condition. The condition I am saying. The condition box ABC. Box ABC can be written as A bar dot, general notation I am saying, A bar dot B cross C. A bar dot B cross C. Whenever he did not discuss about the angle, we can try to understand that this one you should write dot product as modulus of A bar into modulus of B cross C into the definition of dot product of A bar cos of A comma B cross C. Until otherwise we did not discuss about the angle, we know that B bar cross C bar is the perpendicular vector to both B bar and C bar. So B bar and C bar, let us discuss about, this is B bar and this is C bar. This is the perpendicular vector to both B bar and C bar. So the vector B cross C is perpendicular vector both B bar and C bar. Then if A bar is parallel, so B cross is nothing but A. So regarding the IJK concept, using IJK also you can say, simply I am saying the obvious condition here. So what the angle becomes between A bar and B cross C? Whenever A bar is perpendicular to both B and C and B cross is perpendicular to both B and C, then the angle between A bar comma B cross C becomes 0 because they are parallel. So here you can write the value cos 0. So cos 0. In some problems we may get the value like this, cos 0. Next you can write modulus of A bar into modulus of B cross C into cos 0 value 1. In next step we can write modulus of A into modulus of B into modulus of C into here sin of B comma C. Whenever B or C are perpendicular vectors, this one I am discussing about mutually perpendicular vector. If condition I am writing, if A bar, B bar, C bar are perpendicular vectors, mutually perpendicular or mutually orthogonal, that implies here you can write modulus of A into modulus of B into modulus of C into sin 90 degrees. Therefore, you can write here box ABC. Box ABC is equal to mod A into mod B into mod C. This is an important bit. If the condition, if A, B, C are perpendicular vectors, or if A bar, B bar, C bar are mutually perpendicular vectors, then box ABC is equal to mod A into mod B into mod C. If they are unity vectors also, then you can say that box ABC is equal to 1. Now, let us discuss about coplanarity conditions. Regarding box ABC, we discussed about plane or coplanarity conditions. We can discuss now. Fifth one, 5 properties completed. Next, let us discuss about sixth one. Condition of coplanarity. Let this is a plane. This is a plane. Let this is O bar and P bar here. This is A and this is B and this is C. Let us discuss about the property of the coplanarity conditions. A, B, P, C here are coplanar. A, P join the letter. A, C also you can join. Condition of coplanarity. Condition of coplanarity. We know that in previous classes we conclude that whenever more than 2 vectors, 3 vectors or 4 vectors are coplanar, then their determinant is 0. Using this, if condition of coplanarity I am writing, if A, B, C are coplanar with respect to the given vector, position vector P. If A, B, C, comma P I am writing. If A, B, C, comma P lie on same plane, A bar, B bar, C bar, P bar lie on same plane. They lie on same plane, then the vectors what we joined AB, AB, AC. The vectors AP bar, AB bar, AC bar, AP, AB, AC, AP, AB, AC are coplanar. So we can say that the vectors are coplanar. Whenever the vectors are coplanar, then there we said that the determinant is 0. Here we should say that the box is 0. Condition of coplanarity of 2 vectors. Box here AB, AB, AC is equal to 0. So we can write here OP bar minus OA bar. OP bar minus OA bar, and you can write OB minus OA, and you can write here OC minus OA. Let us denote the vector. This is box determinant model. R bar minus A bar. R bar minus A bar, B bar minus A bar, C bar minus A bar. A condition of coplanarity I am discussing with you. This is 6th property, 6th formula. You can write here R bar minus A bar dot, R bar minus A bar dot, B bar minus A bar cross C bar minus A bar. That is equal to R bar minus A bar dot, multiply with this one, B bar cross C bar, B bar cross C bar minus B bar cross A bar, B bar cross C bar minus B bar cross A bar, multiply with these two vectors, b cross c minus b cross c minus a bar cross c bar. Minus a bar cross c bar. Later no need to write a cross a is 0, we know that. Next you multiply the vector r with everything. That is equal to r bar dot b bar cross c bar minus r bar dot b bar cross a bar. R bar dot b bar cross a bar. Next you can write r bar dot a cross c minus a bar dot b bar cross c bar minus a bar dot b bar cross a bar minus of minus it becomes plus. It is also plus. A bar dot a cross c. Here I say the property. In previous bit I said that a dot b cross a also can be written as a cross b dot a. Here I am writing the property dot and cross can be interchanged. Dot and cross can be interchanged. This is a main property. Whenever dot can be cross interchanged here, you can write a dot b cross a as a cross a dot b. Then whenever the two letters are in the box, the value is always 0. Whenever two letters are in the box, its always value is always 0. So this is 0, this is 0. Now you can write condition of coplanarity. What I said previously, we should write here this is 0 because determinant value is 0. This is 0. So total this one also 0. Now that implies, you can write here this is that implies box RBC. Box RBC minus box RBA minus box RAC is equal to box ABC. This is the property. Condition of coplanarity is this is the property. And RBC, you can write here RBC, box RBC. Here you change this one as, better to leave like this because R like that is there. So leave this one. This is also known as equation of plane passing through 3 points. This is the condition of coplanarity, and this is also known as, this is the equation of plane we have find out because AB, AC are coplanar. This is also known as equation, that too vector equation should write. Vector equation of plane. Vector equation of plane. This is also known as vector equation of plane passing through. Vector equation of plane passing through 3 points A bar, B bar, C bar. The vector equation of plane passing through A bar means capital A position which is having position vector A bar, and capital B having position vector B bar, and capital C having position vector C bar. So let us discuss about another planes also. Another plane equation. This is the condition of coplanarity, the equation and the condition of coplanarity also we got. This is vector equation of plane. Next, using A, B, C, D also we can say. If a vector P bar is coplanar with A, B, C, D, we got this. And another bit is also there. Let us discuss about condition of coplanarity. Condition of coplanarity of 4 vectors. Condition of coplanarity of 4 vectors. OA is equal to A bar, OB is equal to B bar, OC is equal to C bar, and OD is equal to D bar. It is general notation I am saying. Condition of coplanarity is box AB, AC, AD. Box AB, AC, AD is equal to 0. Same concept, students. This can be written as here B bar minus A bar. Here C bar minus A bar, because the position vector I am writing, position vector concept O second letter minus O first letter. Next here you can write D bar minus A bar equal to 0. So next step, B bar minus A bar. B bar minus A bar dot C bar minus A bar cross D bar minus A bar. This is the direct bit in M set is equal to 0. That implies B dot, I am multiplying later, you can multiply after completion of inside multiplication. You can write here C cross D. C cross D minus C cross A. C cross D minus C cross A minus A cross B. Okay. Minus A cross D is equal to 0. Plus A cross A did not write. That implies this can be written as B dot C cross D. You can write directly box BCD notation. Box BCD minus you can write here box BCA. Box BCA we can write box ABC also. Next you can write here box BAD. Next step box ACD. Next step I am not writing because box ACA becomes 0. This is 0. Depends upon the condition of coplanarity. We can write here condition I am writing. Condition of coplanarity of 4 vectors. Condition of coplanarity. Condition of coplanarity is box BCD. Box BCD. Box BCD. Here plus you can write plus box ABD. Box BCD plus box ABD. Here plus you can write CAD. Plus box CAD is equal to box ABC. This is the direct M set bit. In mains 2000, in those days AAA is there. 2012 he given the condition, simple condition he given in 2012, and this is M set bit also, direct M set bit. Next, let us discuss about equation of plane in another 2 forms. Equation of plane in another 2 forms. 7 properties I discussed. Now let us discuss about 8th one. Vector equation of plane I am reading. Vector equation of plane passing through. Vector equation of plane passing through 2 vectors. Later 1 vector. So reducing 3 vectors I said. Next 2 vectors, next 1 vector. Passing through 2 vectors. Passing through 2 vectors, the position vector OA equal to A bar and OB equal to B bar, and parallel to another vector. Vector equation of plane passing through 2 vectors OA equal to A and OB equal to B, and parallel to another vector C bar. Parallel to another vector C bar is the formula box AB into C. Here C, box AB C equal to 0. Let us draw the diagram. P should be position vector. This is O. Here A is there, and the plane passing through 2 vectors AB. Let it be B here. Let it be P here. AB. Here P right. The vector, the plane is passing ABP and it is parallel to another vector B. So this is parallel condition. This is good. In previous sum I said that this is capital B. In previous sum C also on the plane. So the point, the vector equation of plane I am discussing passing through AB 2 vectors, and P should be a normal vector. P should be a position vector. Position vector concept OB is R bar, and this is OA is A bar and OB is B bar. It is C bar. Parallel to C bar. Okay, now let us discuss about this one. Position vector concept R bar minus A bar into AB. Here you write AB means B bar minus A bar. B bar minus A bar. Don't write into here, simply C bar. This is the box equal to 0. Now next step, let us write R bar minus A bar dot B bar minus A bar cross C bar equal to 0. Next, you can write R bar minus A bar dot, you can write here B cross C minus A cross C equal to 0. B cross C minus A cross C. Set bracket I put here. Equal to 0. Multiply with R bar. You can write here box RBC. Box RBC minus box RAC. Box RBC minus box RAC minus box ABC equal to 0. I did not write here A box AAC because it is 0. So you can say that this value box RBC minus box RAC. Box RBC minus box RAC equal to 0. Whenever R is there, simply you leave it. Because the vector equation starts with the position vector R. Box RBC minus box RAC equal to box ABC. Now, let us discuss about ninth formula and discussing vector equation. Vector equation of plane passing through. Vector equation of plane passing through. Passing through a point. Simply a point. A point capital A bar, and parallel to, passing through a point and parallel to two vectors. Parallel to two vectors B bar comma C bar is box AP BC. Box AP, these are small letters. Whenever he said 2 points, position vector AP, AB like this you should write. Later, whenever he is discussing about only one vector parallel, simply small letter will indicate. Here AP, BC are small letters. Let us draw the diagram. Simply one point is there, let this point is A, this is P, this is O, OA, OP, this is AP. The plane passing through A, simply A, and it is parallel to BC also. So whenever the plane passing through a point and parallel to BC, we can say that the plane is the plane contains A, B, BC also. So we can say that A, P, BC are coplanar. That is why whenever coplanar condition is there, condition of coplanarity we discussed as box APBC. That implies condition of coplanarity. Once again I am discussing with you. Condition of coplanarity. Condition of coplanarity here, box APBC equal to 0. In addition of vectors, we discussed the same concept, vector equation of plane passing through a point, 2 points, 3 points. In those, it depends upon only scalars. Vector equation of plane passing through a point and parallel to, simply vector equation of plane passing through a point and parallel to two vectors. I said that R bar equal to A bar plus SB bar plus TC bar. Here this is entirely different. This is condition of coplanarity. There we discuss vector equation of plane passing through 2 points and parallel to another vector. R bar is equal to 1 minus T into A bar plus TD bar plus SC bar. Next let us discuss about vector equation of plane passing through 3 non-planar points. R bar is equal to 1 minus S minus T into A bar plus SB bar plus TC bar, like that we said. But this is entirely different. That is depends upon additional vectors, only scalars. And here this one depends upon condition of coplanarity and the values of determinants. So you can write here box OP minus OA. Box here OP minus OA, R bar minus A bar, B bar, C bar equal to 0. You can write here R bar minus A bar dot simply B bar cross C bar equal to 0. Then you can multiply, you can say that the simple value box RBC is equal to box ABC. Generally, I used to say first this one, second this one, third that one. But reverse I said. No problem. Try to understand that here, whenever passing through a point and parallel to two vectors, you got only one box RBC equal to box ABC. Whenever it is passing through 2 points, 2 values you got here. Whenever passing through 3 points, 3 values you will be getting there. But right side box ABC is common for the vector equations. Only for MSET I discussed this one. Next, let us discuss about properties of a dot and a cross. I mean box ABC. Regarding the property of box ABC, two properties are there. Later we can go into another concept. Let us discuss about 10th point. Box A bar, B bar, C bar whole square notation. Notation of box ABC whole square. We can say that here A dot A bar, A bar, A dot A dot B, A dot C. This is the determinant property. Here B dot A, B dot B, B dot C. Here you can write C dot A, C dot B, C dot C. This is the diagonal matrix. You try to understand A, B, B, C, C. A square, B square, C square. Remaining letters are like this. Box ABC whole square. Next, let us discuss about this. Should be discussed in the next topic, vector triple product. But it is most important. We will be facing in theory bits, level 1, level 2 and everything. Everywhere we will get the value. That is why I am discussing now only. Most important value. Plenty of times this bit given directly or indirectly in mains. In MSET also plenty of times he given. The point is box A cross B, B cross C, C cross C. Box A cross B, B cross C, C cross A. Box A cross B, B cross C, C cross A. Or box B cross C, C cross C, A cross B. No problem. Anyhow you can write here. This can be written as box ABC whole square. This is the most IMP formula. Box A cross B, B cross C, C cross A. Box ABC. A cross B, B cross C, C cross A. Let us discuss about this proof. Let us take LHS. LHS, we should write here box A cross B. Box A cross B, B cross C, C cross A. Box A cross B. It can be written as A bar cross B bar dot A bar cross B bar dot B bar cross C bar cross C bar cross A bar. Like that. Let this vector is M. Now let us discuss about that one. That is equal to, next step we can write here A cross B dot A cross B dot B bar cross C bar cross M bar. I said that the anti-corruption bureau concept in day before yesterday. So A bar cross B bar dot, we can say that the value, vector value B bar dot M bar, B bar dot M bar into C bar. First letter into third letter, like that. First letter dot, third letter into second letter, minus the vector which is outside you should be put inside, and the vector which you used, the letter should not be used. So B, C, M is there. B, M, C you had written. B here you used. So here you should write C bar. C bar dot M bar into the vector which is outside you have taken inside, and three letters are there, another letter take outside. So B bar you write here. Now let us discuss about this one. A cross B, next let us write, that is equal to A cross B. Leave here A cross B. A cross B into B, M is there. What is the value it taken as M? C cross A. So B dot C cross A I am writing. B dot C cross A into here C bar you write. Next letter C bar dot M meaning C cross A dot B bar. I said that dot and cross can be interchanged whenever two letters are there in the box. You can write it is directly 0. So that is equal to A bar cross B bar. A bar cross B bar is outside into box, you can write here box BCA. Box BCA into C. You can write here because dot product is commutative. Means A bar dot B bar equal to B bar dot A bar. Anyhow you can write C here also you can write.
So it becomes box ABC into this is box ABC. Box ABC into box ABC is equal to box ABC whole square. Dear students, don't forget the value most important. This one, box A cross B cross C cross A is equal to box ABC whole square. Depends upon this some plenty of times he asked in mains bit. Sometimes he used to ask direct value A cross B cross C cross A. Sometimes he used to ask A cross B cross C cross A is equal to AB box ABC whole power lambda. What is the value of lambda? Sometimes depends upon this sum. A box ABC power 4 is equal to this one. So what is the missed vector? So what is the missed vector? Power 4 is there. Then 4 square you should write here like that. So box A cross B cross C cross A whole square means becomes here box ABC whole power 4. Don't miss this concept. It is important concept. Box A cross B cross C cross A is equal to box ABC whole square. Now let us discuss about skew lines. We completed the topic regarding properties of dot product, properties of scalar triple product of vectors, and now we entered into vector triple product also. Without our knowledge, we must enter. This one important concept completed. Now let us discuss about the definition of skew lines. Skew lines. In 3D lines, I said that skew lines. Two lines L1 equal to 0, comma L2 equal to. Two lines L1 equal to 0, comma L2 equal to 0 are said to be. Two lines L1 equal to 0 and L2 equal to 0 are said to be skew lines. Said to be skew lines. If there is no plane containing both of them. If there is no plane containing both of them. There is no plane containing both of them. That means, let this is a plane. That wall is a plane. This board is this is a plane, and down place is a plane. Where I stand, it is a plane. So here it is a vector. Let us try to understand that a vector is on the board and vector is in another room. A vector is on the board, a vector is on the floor, like that. Here the two, this is another plane and that is another plane. The definition is two lines L1 equal to 0 and L2 equal to 0 are said to be skew lines if there is no plane containing both of them. If try to understand that a vector is in this room and another vector is in another room, like that. We can say that the two lines never intersect, neither parallel. Skew lines are, I am writing here. Skew lines. Skew lines are neither intersect nor parallel. Skew lines are neither intersect nor parallel. So parallel condition or perpendicular condition or anything is not possible. Let us denote like this. This is L1 equal to 0. This is L2 equal to 0. Simply leave it like that. Don't join the two lines. We should calculate now the shortest distance between two skew lines. This can be written as here A. This is A bar. This vector parallel to B bar we can write. Otherwise here you can put B also. If sometimes B may be B bar. Sometimes he used to give like this, R bar is equal to A bar plus SP bar. So the vector parallel to the line parallel to the vector B bar. Here C, position vector C bar. Here you can write dr. Sometimes he can say this line parallel to D bar. So we can write the equation R bar is equal to C bar plus TD bar. These two lines L1 equal to 0, L2 and L2 equal to 0 are said to be skew lines. And now we can write here the definition of the formula of shortest distance. Shortest distance between two skew lines. Shortest distance between two skew lines. In IB you learnt, here also it is an important topic. In MSET compulsory one bit will be there regarding this skew lines topic.
shortest distance between two skew lines is equal to modulus of box A minus C BD whole by modulus of B cross D. If, note I am saying, this is 12th point, note, if the lines, I am not writing here skew lines, if the lines intersect, whenever the lines intersect, there is no distance because they intersect at the common point. This is L1 equal to 0 and this is L2 equal to 0. If the lines intersect, then you can say that box A minus C B D equal to 0 because there is no distance. Box A minus C, denominator no need. Box A minus C B D is equal to 0. Next one, skew lines we completed. Let us discuss about parallel lines also. 12th one. R bar is equal to A1 plus SB bar, I am writing, and next R bar is equal to A1 plus SB bar, and R bar is equal to another vector A2, A1 plus SB bar plus, and in another line R bar is equal to A2 plus TB bar. Here I am discussing about the same scalar. You can write here like this. This one A1 plus SP bar, first line. This one A2 plus TB bar, second line. Now we can write that distance between two parallel lines. Distance between two parallel lines. This is about the topic of 3D lines. Distance between two parallel lines. Distance between two parallel lines is equal to modulus of A1 minus A2 cross B bar by modulus of B bar. During the same concept, box A minus C BD concept, here modulus of A1 minus A2, because B bar is the same vector, you can do nothing. So box modulus of A1 A2 cross B bar by mod B bar, that's all. Let us discuss about the condition of coplanarity completed, the skew lines completed. Okay, now let us discuss about the sums. Scalar triple product of vectors concept completed. So then let us go for sums. According to our material, theory bits, worked examples I am giving homework to you. In level 1 classwork, some bits I will say. Level 1 classwork, which are important. And next one is also there, students. Reciprocal system is there. Let us finish it. Reciprocal system. 13th one. Let us put aside it. Reciprocal system. Reciprocal system. If A bar, B bar, C bar are three vectors. A bar, B bar, C bar are three vectors. A bar, B bar, C bar are three vectors. Then A dash, B dash, this is bar. Don't think this is inverse. A bar dash, B bar dash, C bar dash are said to be, A bar dash, B bar dash, C bar dash are said to be reciprocals, are said to be reciprocal vectors, said to be reciprocal vectors of A bar, B bar, C bar respectively. A bar, B bar, C bar respectively, if the notation of A dash is equal to B cross C by box ABC, B cross C by box ABC, comma. B dash bar is equal to C cross A by box ABC. Next, C dash is equal to, C dash bar is equal to A cross B by box ABC. Depends upon the topic properties of triangles. One letter
if A dash we want box ABC is common for everything. A dash we want A letter should not be. B dash we want B letter should not be. C dash we want C letter should not be. Like that. Therefore, box then in this case then box A dash B dash C dash. Box A dash B dash C dash is said to be reciprocal system. Said to be reciprocal system of A bar, B bar, C bar. Said to be reciprocal system. Now we can say that. Now the property, next property, 14 will last bit. We can say that A bar dot box, A bar dot A dash. What is the A bar dot A dash? A dot, the A dash became B cross C by, already we had written the formula in the denominator as box ABC. So you can say that A bar dot B cross C is equal to box ABC. Box ABC by box ABC is equal to 1. Therefore, also I am writing A dot A dash became 1. Then B dot B dash equal to also 1. C dot C dash. C dot C dash is also equal to 1. These are said to be reciprocal system of vectors. Next, box also we can say that box A dash B dash C dash. Box A dash B dash C dash is equal to 1 by box ABC. Simply the notation is reciprocal. The definition is reciprocal, written in the form of mathematical symbol. That's all. Now the concept we have completed, students. So let us discuss about the sums. I am giving work to you that you complete worked examples. Everything you do easy only. Every worked example is previous MCET question or previous mains question. Next one, theory bits also you do. You can do, sure. In module 1, 16th question, I want to discuss, but already discussed. Here B cross C, C cross A cross B is equal to box ABC whole power K given. Box of B cross C cross A cross B given. Box of B cross C, 16th one, level 1 class work I am saying. Box of B cross C cross A cross B is equal to he given as box ABC whole power K. I said that he may ask here box ABC whole power lambda like that. Previously we discussed the proof and discussed about important also. Box B cross C cross A cross B is equal to box ABC whole square. So here K is equal to 2 because it is box ABC whole square. So 16 I want to discuss, completed. Let us discuss in level 1 some problems 19, 22, 23, 24, 26 like that. Total 26 sums are there. Scalar triple product of vectors. Topic is scalar triple product of vectors. Scalar triple product of vectors. For the topic scalar triple product of vectors, I want to discuss with you level 1 class work. Only some questions. 19th one. Regarding this concept, what I said. 19, 22, 23, 24, 25. Enough. 19, 22, 23, 24, 25. Now let us discuss about 19th question. The vector equation of plane. The vector equation of plane passing through the point, 2 points given. 2 points A bar is equal to I minus 2j. I minus 2j plus k comma B bar is equal to minus 2j plus 3k. Minus 2j plus 3k and parallel vector. Parallel to C bar. Parallel to C bar he given
as 2i plus j plus k. 2i plus j plus k. So we discussed vector equation of plane. Required I am writing. Whenever required you have written, we should get an idea about the formula. Vector equation of plane passing through two vectors and parallel to another vector. The concept I said that box A, two vectors, box AB, C bar equal to 0. So box AB means R bar minus P bar, R bar minus A bar. This is R bar minus, you write I minus 2j plus k. Put the box. According to box he given are options. According to options, like it only he given R bar minus I minus 2j plus k for every option he given. Next, what is the value of AB? B bar minus A bar. This one. So minus 2, now let us write minus I. Minus 2 plus 2, there is no j term. Plus 3k minus k plus 2k. Okay, now C bar directly you can write here 2i plus j plus k equal to 0. These are M set bits to this. According to option, this is second option. Next, 22. 22nd question. The perpendicular distance from origin, to the plane passing through the points. Okay, this is important question. IMP question. For mains also. In 3D lines also we can ask. The perpendicular distance from origin to the plane passing through points. How many points he given? 3 points he given. Let us discuss about A bar is equal to 2i minus 2j. 2i minus 2j plus k. 2i minus 2j plus k. You write here B bar is equal to 3i plus 2j minus k. Next, C bar is equal to given as 3i minus j minus 2k. So, what we should find out what he given? Perpendicular distance from origin to the plane. Whenever he asked perpendicular distance from origin to the plane, now we want to discuss about the Cartesian equation of plane, not vector equation. Regarding addition of vectors, you should not use the formula. Regarding product of vectors also you should not use. You should use only concept, the perpendicular equation of plane. This concept, otherwise box AB, AC, AD scheme. So what is the value of this one only? Box AB, AB, AC equal to 0. So what is the value of box ABC here? You can write here x minus 2. X minus 2 and y plus 2 and z minus 1. This one minus this one, b minus a, you should write here 1 and 2 plus 2 becomes 4 and minus 1, this is minus 2. And next to c minus a, you write 3 minus 2 is 1 and minus 1 plus 2. Minus 1 plus 2, here minus 1 plus 2 is 1 and minus 2 minus 1 is minus 3 is equal to 0. 3 minus 2, we have written 2 plus 2 and minus 1, b minus a concept here, c minus a concept 3 minus 2 and minus 1 plus 2 and minus 2 minus 1. Using this one, you should calculate determinant. So you can write here x minus 2 into 4 3 are 12, minus 12 plus 2 you can write here minus 10. Minus of, now we can write y plus 2. Y plus 2 into 1 minus 4. 1 minus 4 is minus 3. Plus of z minus 1 into 1 minus 4 you can write here minus 3. This becomes minus 10x. Minus 10x plus 20. Minus of minus plus 3y plus 6. Minus 3z plus 3 equal to 0. Let us write the equation of plane using first, second, third order as x, y, z. Minus 10x plus 3y. Minus 10x plus 3y minus 3z plus 26 and 3, 29. constant 29. Let us see the definition. 22nd question, a bar is equal to 2i, 29 is there. Perpendicular distance he is asking. Perpendicular distance from 0, 0, 0, the formula mod d by root of a square plus b square. 29 by this is 100, this is 9, this is 9. So 29 by root 118. According to option, let us discuss about 22nd. He given 25 by root 110. Let us discuss once again. R bar 2i minus 2j plus k, the vector given. Next 3i plus 2j minus k, 3i minus j minus 2k. AP x minus 2, this is y plus 2, z minus 1, 3 minus 2, 1, 2 plus 2, 4, minus 1, minus 1, minus 2, this is minus 2. It's okay. 1 plus 2, everything okay. See 3 minus 2, 1, minus 1, minus 1 plus 2, this is also 1, minus 2, minus 1, minus 3. Determinant, once again we should calculate about verification of determinant. X minus 2 into minus 12 plus 2 minus 10 minus y plus 2 into minus 3 plus 2. Minus 3 plus 2 is there. This is a mistake. Minus 3 plus 2 minus 1. Z minus 1 into 1 minus 4 minus 3. Let us discuss now regarding this y concept. Now we can write here minus y minus 2. Minus y minus 2 minus 3z plus 3 equal to 0. Minus 10x minus y. Once again we should write here the value. Minus 10x. Minus 10x minus y minus 3z. Minus 10x minus y minus 3z. 23 minus 2. Maybe here also plus 2. Minus of minus, this is a plus, students. Plus y plus 2. So plus y minus 3z, 25 it becomes. Okay, now it is okay. 25. Now you can write perpendicular distance from 0, 0, 0. From origin is 25 by root of 100 plus 1 plus 9. That is equal to 25 by root 110. So next, now 22 completed. Let us discuss about 23, 24, 25. 23rd question, the distance between the line and the plane. Oh, he is discussing about a line and a plane. So what is the discussing? 23, line and plane. So line, whatever the passing through point is there, you should calculate about passing through point and later about the plane. 23. Line, first of all I am writing line. Line he given as 2i. R bar is equal to line. Line R bar is equal to 2i minus 2j plus k. 2i minus 2j plus 3k. 2i minus 2j plus 3k plus lambda into I minus j plus 4k, and the plane, line he given and plane he given. Plane equal to r bar dot I plus 5j plus k equal to 5. Whenever you should calculate the perpendicular distance between line and plane, this one, this is the perpendicular distance you should calculate. This is the A bar. A bar. Formula I am writing. Perpendicular distance from a point x1, y1, z1 to the plane formula modulus of ax1 plus by1 plus cz1 plus d whole by root of a square plus b square plus c square. Root of a square plus b square plus c square. Plane pi indicate with the letter pi. Here you can write x plus 5y plus z minus 5 equal to 0. Now let us discuss about This is 2 minus 2, 3. So you can write here 2 minus 10 plus 3 minus 5 whole by root of 1 plus 25. Root of 1 plus 25 plus 1. So what is the value here? 2, 3, 5. 5 minus 15, 10. 10 by root 27. Let us verify the option he given as 10 by 3 root 3 as third option. So perpendicular distance. He did not discuss about perpendicular distance between line and plane, but you should try to understand that the distance is perpendicular. We have completed regarding plane concept. Let us discuss about shortest distance between two skew lines. Can we complete two sums? So shortest distance between two skew lines we can discuss in next class. Okay, now I am stopping the class. Okay.